Hello, it's Mr. Hartzell here at Southside, and we are gearing up for our Common Assessment number 4, the Division Unit. And this is just a quick tutorial as to what our study guide is about, and so we can help our students when we're at home and make sure that we really are prepared to take this Common Assessment and show everybody what we know. This is the guide to mathematical domination because our kids are awesome here at Southside, and I'm sure that they're going to do great. The first thing they need to understand is place value. We need to know what the value of each number is within a set of numbers. This first number we have here is 345,237. We're going to be looking at questions, and they're going to be asking you what the value of a certain number is. For example, if we look here at the value of the 3 in this first set, you're going to find out that the value of that is 300,000. Not to be confused with the 100,000th place. Students will need to know, and they will need to record 300,000 because that's the value of this particular number in the set. And it goes on through the rest of the numbers as well, and you can look at the 4 and see that that would represent 40,000, and then the 5, and that would represent 5,000. Students need to be able to explain why that is represented that way, and why this 3 represents 300,000 and not just 3 or 3 ones, we might call it. One of the other things they need to know is how to use an array. Listed here we have a 5 by 5 array, and we will see that students are presented with a question when they see this. It says, using the array, please divide it into 5 equal parts. Color each part a different color. Students will look at this and decide how are we going to divide this equally. And because this is a 5 by 5 array, these squares are equal on both sides. So then they can divide it any way they would like to. Students could divide it this way and say this is one set of 5, and they can say this is another set of 5. Or students can pick 5 squares in the middle of the shape and shade it in and record that as being 5 also, and then do that on the other ones. What we are looking for here is to see if students can make a connection between this array and between division, if they can divide it the way it should be done. The next thing they need to know is understanding equations and be able to solve for the missing number. I've given them the example x divided by 5 is equal to 40. Now when we look at this, a lot of times we want to say that this would be 8. A lot of students would say that the x would represent 8 because 40 divided by 5 would be 8. But we have to use our inverse property to decide that we need to actually flip this division sign, make it a multiplication, then multiply the two numbers that we have left. When we take the two numbers that we have left and then we multiply them together, we will be given our answer, and x would represent 200. Now it's important that we go back and we check what we have just done. And so if we go ahead and look at the equation, x divided by 5 is equal to 40, we can check this by filling in what we think x might be. So if we do that, we'll take 200, divide it by 5, and then we will try to figure out what our answer is. And if we do that, we can go the long way, and we can find that 5 will go into 20 4 times, which is 20. Subtract that out, bring down the 0. 5 will go into 0 times, won't go in there at all. And so 5 times 0 is 0, and then that leaves us with 0. So we have 40. And we can see that 20 divided by 5 is indeed equal to 40. And so x in this case, we would say x is equal to 200. Now students aren't going to have a whole lot of these questions. It's going to be more of applying this concept to word problems, which we've worked with quite a bit here in the classroom. It's just becoming familiar with that. When we have a division sign, then we need to learn that we need to multiply when it comes to this inverse property. And then we have a multiplication sign. We need to learn that we need to divide that in order to find the missing piece of information. The main thing is, don't let the letters confuse you. Don't let the letters mess up your train of thought. Don't be afraid of them. We're just trying to solve for them. If you're at home and your students are struggling with this, I would just recommend putting a blank and then do divided by 5 is equal to 40, and just have your child fill in the blank. Maybe this will calm them down Whatever method they use on the test is fine as long as they aren't asked to write an equation. And if they are asked to write an equation, they will need to provide a letter to represent that missing number. Be able to use multiplication and division to solve word problems. That's the main thing that we need to know, is to be able to solve these problems. Is multiplication and division go hand in hand, and they need to be able to do both of them well in order to succeed on this particular assessment. I need to be able to solve multi-step word problems that contain whole numbers. That means there's no remainders, as well as problems with remainders. Students will have both of those on this particular assessment, and we've worked on those over and over and over again in the classroom. And the main thing is students need to know how to interpret those remainders. We can't just leave the remainder at the bottom of the page. We have to know what to do with it. We also need to make sure that our answers are reasonable. We can't say that our homework isn't turned in because our dog ate it. That's not a very good reason. We need to provide proper reasoning when we have our short answers, when we have our open responses, and even just our general multiple choice. We need to make sure that our answers make sense. Going back to the problem we just did, it wouldn't make much sense for 8 divided by 5 to equal 40. That just doesn't make sense. Okay, and so we need to assess the reasonableness of the particular answer that we're writing down and make sure that it indeed does make sense. And we can always go back and check the division problem with a multiplication problem, as we did before. We also need to be able to estimate and round. One of the examples I've given is Joe has 298 pencils. About how many pencils does Joe have? The key is about. About is not an exact answer. Exact means exact, and about means you need to estimate. So we need to figure out how many pencils Joe has. For this particular number, 298, students would be asked to round to the nearest hundred, and therefore students would be looking for the number 300 for their answer, for their final product. Another example with that would be Sheila was paid $383 working at the flower shop for 4 weeks. About how much did she earn each week? What we would do here is we would take the total we have for the working, how much she got paid for the work month, and we would take 383, and that would become our dividend. That would go inside the house, as the students might say, and then the divisor would be 4, because this is the total. $383 is the total she was paid for working 4 weeks. And so we're trying to figure out about how much did she earn in each week. And because the dividend does not end in an even number, we know that we are going to have remainders, and students need to know how to interpret those. In this particular case, students just need to write the total that they think they got paid, and they need to round up to the nearest dollar. Moving on, students also need to know their factors. They need to know what is not a factor of 45. They need to know what is not a factor of other numbers. And the main thing is they need to understand their factors. The example that I gave them in class was I took the number 36 and I asked them to do 36 divided by 1, 36 divided by 2, 36 divided by 3, 36 divided by 4, 36 divided by 5, 36 divided by 6. Now in doing this, they're able to see, can we actually divide this and it be a whole number without remainders? And so if we take 36 and divide it by 1, we're going to be given the quotient of 36. And so what we're going to do here is we're going to circle the 36 because this is our quotient, and we're going to circle 1. And we'll see where this all connects here in a moment. 36 divided by 2. The question we have to ask ourselves is, can we do that? Is 36 divisible by 2? And we know that because 36 is an even number and 2 is an even number, it absolutely is going to go in, especially since this is a 2. We can always divide numbers that end with an even number by 2. And so in doing that, 36 divided by 2, we know is 18. And so we're going to circle the 18, and then we're going to circle the 2. 36 divided by 3, we know that that is 12. We circle the 12, we circle the 3. 36 divided by 4, that is 9. Circle the 9, we circle the 4. Now 36 divided by 5, 5 will not divide evenly into 36. And so we're just going to go ahead and cut this out, forget that it was there, and then move on. And then 36 divided by 6, we know that that would be 6 as well. Now when we start repeating numbers is when we stop doing this. And it's very simple how we list those. We start at the top, and we make a U, kind of like this. And we're just going to list those numbers in order in which they occur on the line. So it would be 1, 2, 3, 4, down here at the 6, 9, 12, 18, and 36. Now we're going to go back and check those. 1 would go with 36, 2 would go with 18, 3 would go with 12, 4 would go with 9, and 6, and that is a square root, and so 6 would be multiplied by 6 to get 36. Students can also use another way. We learned the multiplication. They can use the factor tree method. Whatever way they prefer, they can do those as well, as long as they have the right quotient at the end. We know how to form equal groups. This is a question that we're going to see a lot in the next few weeks, especially as we get into fractions. It says Jen has 14 pieces of candy. Steve had 22 pieces of candy. Homer had 9 pieces of candy. If they divided the candy evenly, how much would each person receive? And this is a multi-step problem. We first need to figure out how many pieces are there total. So we add 14, 22, and 9. In doing that, we will find out that there was actually 45 pieces total. We would take the 45, and then we'd use the second step, and that would be divide that by 3. 3 will go into 4 one time, which is 3. Subtract that down, bring down to 5, and that is 3 going to 15. It'll go in there 5 times. We would end up with 0. And so each person would receive 15 candies.